The following is my explanation for number 61. I know there's a lot of information up here that we didn't talk about or use in class. First of all, we are going to use the calculator to determine easy zeros, always. We're not using any of the root theorems or things that you had learned before. So the point here is we are going to go into the calculator, go into y equals. We're going to type in the function. So we're going to use x cubed minus 2x squared minus 7x plus 2. And we're going to check out the table. When we do that right here at -2, notice we have a very easy 0. Do I have all the descending powers? The answer is yes. So I'm going to set up my synthetic division with the easy 0, -2, 1, -2, -7, and 2. Bring down the 1, multiply, add, 1, -2. As a reminder, if this is in fact a 0, and you typed it incorrectly from what you were given, typed it in to the calculator correctly, this should always come out to a 0. Okay? Now, I just want to review the fact that what we have done with this function is we've changed its form by doing this. This function now can be rewritten as x plus 2, the factor that gave us this 0, times, and we reduce this by 1, x squared minus 4x plus 1, as such. So it's this same form as this, just written, factored out one time. The goal of synthetic division is to take big functions and break them down so we can find the other factors. This factor we already took care of. So when I look at my list of zeros, which I should have 3 of them, I know that -2 is one of them. To find the other 2, I'm going to take the quadratic that's left and use the methods that we know from solving quadratic equations. X squared minus 4x plus 1 equals 0. This does not factor, so we have to go to quadratic formula. -b becomes +4 plus or minus b squared minus 4 times 1 times 1, all of which is over 2a. We simplify this more. 4 plus or minus root 12 over 2. 4 plus or minus 2 root 3 over 2. In order to reduce, you must be able to take from all 3 of these areas. If you can only take from 2, you can't reduce. So my final answer, 2, 1, 1, ends up 2 plus or minus root 3. This is a statement that gives me 2 other zeros, 2 plus root 3 and 2 minus root 3. Now, when you look at the answers, they ask you to give you the factor polynomial completely. The answers are going to look like this. h of t is equal to t plus 2, t minus 2 plus root 3, and then also t minus 2 minus root 3. However, very rarely do we write the roots in this format. We typically will write them in this format. Either one of these would be acceptable. This top one or the bottom one.